In this video we'll be talking about the application component of this topic, which is photocopiers and laser printers. So you need to know how the corona wire works in this application, but you also may be required to outline the whole process. So some materials are poor conductors in the dark and conduct better when they're exposed to light. So these are called photoconductive materials, and selenium is just one example. So this material is used in photocopiers and the property is exploited. So when the selenium is exposed to light, the light helps it be a conductive material. So for example, if selenium is charged when it's in the dark, shining a light on it will cause the electrons to be carried to the surface and neutralize the charge only where the light falls. With this property, you can create areas of positive and negative charge on the selenium. I'll run through the steps of photocopying process. Alright, so first there's a drum or cylinder, and it's coated in selenium. There is a corona wire in close proximity to the drum, and both of these are kept in the dark. So what happens is the drum rotates, and as it rotates, the corona wire sprays the drum or the selenium coating with a positive charge. And as it's in the dark, the charge is maintained. Step 2. So an original image is illuminated by a strip light, and this light is transferred through a series of lenses and mirrors onto the drum. So you can see in this example there'll be a light behind this letter T. The light will pass easily through the white component of the paper and be partially blocked by the black text. As it passes through the lenses, the light neutralizes the drum in areas where it hits. Where the light doesn't reach, the charges are maintained. So where the light hits the drum, the area is neutralized because the drum is also earthed. When you have an image that is neither black nor white, maybe grey, some light passes through, so some of the charge is retained, and then that's how you can get shades on a photocopier. So step 3 is to apply a toner to the drum. Very fine toner particles are mixed with larger carrier particles of iron, which are positively charged. So you can see this iron is positively charged, and you've got these little toner particles that are attracted to it. So near the main drum that is coated in selenium, there's another rotating drum called the magnetic roller. So the roller attracts the positive iron particles, which carry the toner particles. And then as the two drums rotate past each other, the negative toner particles are attracted to the selenium coated drum in the areas where the charge is still present. So because the selenium coated drum is of a greater charge in the areas where it was dark, they attract the toner particles and cover the image in toner. Alright, step 4 is to transfer the image onto the paper. So paper is fed into the photocopier close to the selenium coated drum. It runs past a transfer corona wire before it reaches this drum to apply a positive charge to the paper. As the positively charged paper is fed through, it attracts the negatively charged toner particles from the selenium coated drum onto the paper. And then what you have here is dry, loose toner particles on the paper. So after it passes through this area, another corona wire removes the charge from the paper, resulting in a neutral charged paper. Step 6. So now the image has to be fixed onto the paper. So what happens is the paper with the loose toner particles on it is fed through some rollers. So we've got a hot roller and a pressure roller. So what happens is the hot roller melts the toner, and the pressure roller creates the pressure to fuse the toner into the paper fibers. So this is why paper is warm to touch when you photocopy something, and it also explains why glossy paper provides a better image, as the fibers are finer and the toner is pressed more closely together. So step 7, cleaning up. So the selenium drum passes by a rubber scraper, removing excess toner that might not have been transferred properly. The drum is also exposed to a bright light, removing any of the charge. So as the drum rotates, it is ready to use again. Now, when comparing laser printers to photocopiers, they're essentially the same thing. However, instead of using a light that is filtered through mirrors and lenses, laser printers use a finely focused laser beam, and it turns on and off millions of times per second to create the image. You might have heard laser printers being described in terms of their resolution, the dots per inch that they can print. So a laser printer that has 300 dpi, for example, turns on and off 300 times per inch, and this provides the resolution of the image. And of course, higher dpi means better resolution. Unfortunately, laser printing, however, requires a lot of energy, and it can actually initiate the breakdown of oxygen to ozone, so not very environmentally friendly.